Hello. In this video we're going to do a recap of the investigation we did that was called Speedy Squares. And there were two parts to Speedy Squares and a whole bunch of little subparts, but I'm just going to go over kind of like the main idea of the first part so that everybody's on the same track, because everybody designed their own like kind of little house and they did their own kind of way, but I just want to kind of pick out like one way of doing this so we all have like the same basic understanding. So for Speedy Squares, I asked you guys how long it would take you to build. At first, I asked you how long it would take you to build a 26 by 26 square out of licking cubes. So you had here your T chart where you had side length and time, and you couldn't do a side length of 0 because, well, 0 is 0, 0. And if the linking cubes were like one square themselves, so if you picked one up, well, then you're done. And so it takes you like 0 seconds or less than 1 second. So start off by making a 2 by 2 square, so squares with side length of 2, and let's just say that that took, I don't know, 10 seconds. If it was 3, let's say that it took a 3 by 3 square, let's say that it took 25 seconds, and if it was 4, let's say that it took 42 seconds. 5 by 5 square, well, it probably took somewhere in the neighborhood of 70 seconds. But let's just go with those numbers for now. Now, further on, I asked you what was the independent variable. So just did a little bit of data gathering. So you guys were measuring how long it took you to build a 2 by 2 and a 3 by 3 square. And so for the independent variable, it was a variable that we changed, and we were changing the side length, so the size of the square. So in this case, our independent variable is going to be our side length. Our dependent variable will then be the time it took us to make the square in seconds. And after that, I asked you to create a scatter plot that we could use. So we have 2 and 10, so that's 1 point, 3 and 25, that's another, 4 and 42, 5 and 70. So that kind of gives us data like that. So once I created a scatter plot, it's always good to make a line of best fit. So when we have a line of best fit, then we're able to kind of like extrapolate based on the data we have. Because I don't really know how long it would take me to build 1 and 0, because I can't really do that. So I can only plot the data I have, but I can use that data to make a kind of prediction. And if I do that, then I'm going to get something kind of like this. And just kind of extend it back here to kind of maybe where it's going to cross the y-axis, because that's an important point. So, and it'll probably kind of go up like that. So once I've done that, I look at my data and I'm like, oh, it looks linear, and drew a line, so that looks linear. And now I want to try to write an equation, and I'm going to write in the y equals mx plus b. So I have to first find what my slope is. So I can look at just some data that I have. So I can take 2 points. So I got 1 point kind of right here, right at 5 and 60. And I have another point, well, let's use this point just above the one I had at 3. And it's probably going to be closer to, I don't know, let's say 28. And from that, I can use my rise or my run, my slope formula, to figure out my slope. So in this case, my slope rises all the way from 30 to 60. So my slope is going to be 30, or 60 minus 30, which gives me a total of 30. And my run, well, it's going to be from 5 to 3. So 5 minus 3, which equals to 2. So my slope is going to be 30 divided by 2, which gives me 15. So my equation so far is going to be y is equal to 15x plus b. Now I just put the plus in here because that's like the convention, but I kind of know that my y-intercept is going to be negative because it's down here below 0. But I have to try and find it. So to find it, even though I've got now 3 variables, y, x, and b, well, I can find the b fairly easily. I just have to take one of the points. So in this case, I'm just going to take one of the points being, let's say, 5 and my point 5 and 60. So I'm going to take point 5 and 60, and I'm going to sub that into my equation. And I'm going to show my work just down here. So I have the equation y equal 15x plus b. I'm going to sub in my point, 560, 5 for x, 60 for y. So I have 60 equals 15 times 5 plus b. Keep that in brackets. So I have 60 equal to 15 times 5. Well, that's going to be a bigger number. 75 plus b. So I'm going to bring my 75 over, and I'm going to have to change the sign. So it's going to become negative 75 plus 60 equals b. Now once I've done that, well, negative 75 plus 60, well, it's going to be negative 15. So that's going to be equal to my b. So just divide that right now. So I've now figured out that my equation is negative 15x minus 15. And to figure out how long it would take me to build my 26 by 26 square, well, 26 is my side length. So my side length is my independent variable, or also known as my x value. Dependent variable is going to be y. It also makes sense. I got the time going up the y-axis and side length going down the x-axis. So I'm going to write out my equation. Y is equal to 15x minus 15, and just try to find out. So 15 times 26, so that's my side length, minus 15. I got a calculator beside me here. I'm just going to multiply it. So it's 390. 390 minus 15 is 375. So y is equal to 375 seconds. So 375 seconds, well, how many minutes is that? Well, 375 divided by 60. Y is equal to 6.25 minutes. Well, that's actually pretty fast. But I suppose you guys get the point. And it was based on this data that we then expanded it into which is how long it would take us to build this like Lego house based on James May's Lego house, and just kind of extrapolate from there. All right. So if you guys have any further questions, please come see me.